everybody. Today we're going to keep looking at multiplication and division and just continue to work on making sense of both of these operations or these math things that we do. So I've written on here sort of a guide for multiplication and division here at the top that we're going to refer back to, okay? So I want to take a step back and make sure we understand what it means to multiply. So if I have something like 3 times 5 equals n, remember we're using letters now, a number, that simply means that I either have 3 groups times 5 things in each group to get my total number of items I have all together. And that would look like this. I have 3 groups, 5 items in each, and n would equal my total number of items, or 15, because I can go 5, 10, 15. Okay? It also could mean, let me just move this over here. This is one representation. It also could mean 3 items in each group with 5 groups, 1, 2, 3, 4, 5, 3 items in each group, for a total number of items, which would still end up being 15, because here's 5, 10, 15, here's 3, 6, 9, 12, 15. If we wanted to represent this as a division problem, we will always start with the total number of items. So notice, in multiplication, your total number of items is separate on the opposite side of the equal sign from your number of groups and the number of items in each group. And remember, you can also write it as n equals 3 times 5, or n equals 5 times 3. So your total would end up being on the left. That's okay. But the idea is, in a multiplication, your total is on its own on one side, okay? Not with the other parts. The two smaller numbers, excuse me, the two factors are going to be together on the opposite side of the total. When we look at division, we are always going to start with our total. So our total number of items in this case is 15. So we would start with 15. And then we can either divide it by the number of items in each group. The number of groups, which could be 3, to get us how many end up in each group. Wrong thing. Okay, so we could have 15 items divided into 3 groups to show that we have 5 in each group. Okay, that is represented right here. We have 15 total dots, 3 equal groups, 5 in each group. Okay, or we could have it represent 15 total items. Remember, division always starts with our total. And it could mean that there are 3 items in each group to make 5 groups. That's represented here. Do you notice how it's the same division sentence, but it's represented differently? Because you can determine, you can decide, is this number here representing our number of groups or how many in each group? But notice the relationship here. Multiplication and division always have to do with a certain number of items in each group, a certain number of groups, and then the total number of items. Those are always the 3 parts. Now, it could be, rather than groups, it could be the number of rows. But rows are a type of group, right? So I could represent it with an array before we get to that word problem. Let me just make this a little bit smaller here. Push this over here. So I could show it as an array. 3 rows with 5 in each row equals a total of 15. That's still a number of groups. That's the number of rows with how many in each row or how many in each group equals the total number of items all together. Okay? Same with division. Just get that orange back on there. If I were to use an array for division, I could say I have a total of 15 x's. I've divided them into 3 rows, and I ended up with 5 in each row. Okay? It's always those same 3 parts. Total number of something, the number of groups there are that you made of those things, and how many were in each group. So let's take a look at a word problem today, because you are going to be using some letters to represent numbers and think about what that means. And you're going to be asked to write an equation that matches some word problems. You don't even have to solve those word problems. I just want to know today, can you figure out what is the correct equation that matches the story? Your challenge, if you would like to do it, if you have the time, is to then go ahead and solve those problems. So let's take a look at this example. Wyatt sees 7 beetles at the park. Each beetle has 6 legs. How many legs did Wyatt see? Now remember, I know multiplication and division always include a total number of something. Oh man, I can't write today, guys, sorry. It always represents a certain number of groups. And it always has how many in each group. I'm trying to figure out in this word problem, what parts do I already know and what part do I not know? So let's represent our total is going to be red. If we know the total, it's going to be red. If we know the number of groups, that's going to be orange. And then if we know how many in each group, that's going to be green. So I'm going to color code this. Wyatt sees 7 beetles at the park. Each beetle has 6 legs. How many legs did Wyatt see? Okay, so it sounds to me, when it says how many legs did Wyatt see, that there's going to be a lot of them, right? There's more than just 6, because each beetle has 6. So it sounds like my total is going to be how many legs Wyatt saw. That's what I'm going to be looking for. If I think about the other part, Wyatt sees 7 beetles at the park, and each beetle has 6 legs. Well, there's that nice word, each. That correlates right here. How many in each group? So that tells me this is how many in each group. Each beetle with 6 legs. So the number of beetles must be how many groups, right? Thinking of each beetle as a group. So I would then write a number sentence that represents this. I have 7 beetles. That's my total number of, not my total, but my number of groups, times 6 legs on each beetle to give me a total number of legs. And I'm going to write a fancy cursive L to represent legs. Okay? So this problem is asking me to do 7 times 6 to find the total number of legs. Then you can go ahead and solve by using some strategies. A lot of you are getting really good at breaking up your 6 into some parts. So I would do 7 times 1 plus 7 times 5 to find my total. I know 7 times 1 is 7. 7 times 5 is 5, 10, 15, 20, 25, 30, 35. And then if I add those two together, I get 42. So L is equal to 42. Now remember, that's sort of an extension today. You don't necessarily have to solve it unless you've got the time. But what I do want to see is that you know how to write a number sentence that looks like this, that matches our word problem. Now, if some of you said, I could write L, the total number of legs, divided by 6 beetles, the number of groups, equals 7, whoops, sorry, I got it mixed up. It is 7 beetles equals 6 legs on each beetle. That wouldn't be wrong, but it doesn't match our story. We want to make sure our number sentence matches our story, and in this case, we don't know the total, so that's what we should be looking to solve for. Okay, so this number sentence here makes more sense. Let's take a look at just one more. James, because we know James really likes Legos, builds 4 towers out of Legos. He uses a total of 32 Legos. If he uses an equal number of Legos for each tower, how many Legos does he use per tower? All right, I'm going to do something. I'm going to take this guy right here, because remember, we know whoops, let's just copy this and we'll paste it down here. We know every multiplication and division problem has these parts: a total, the number of groups, and how many in each group. So let's break down James's word problem to see what part is what. So let's see if we know the total. James builds 4 towers out of Legos. He uses a total of 32 Legos. Well, goodness gracious, look at that word total. It's right there. So we know the total. He uses 32 Legos. If he uses an equal number of Legos for each tower, how many Legos does he use per tower? So if I think about, do I know the number of groups or how many in each group? I know the number of groups because he makes 4 towers. I could represent it like this, right? Here's 1 tower, 2 towers, 3 towers, 4 towers. That's my groups. What I don't know is how many Legos he uses per tower. That's what I have to find out, right? So I know my total. I know how many groups, but I don't know how many goes in each group. Now I'm going to scroll back up to the top. Is this a multiplication sentence or a division sentence? When we know the total, let's look up here. When we know the total, we want to use division because we're going to start with the total and then we're going to divide it by the other part we know to get the last missing part. So this is a division problem because we know the total. We know there's a total of 32 Legos. We know he breaks it up into 4 equal groups or 4 towers. What we don't know is how many Legos he uses for each tower. And look at that, I used another L word, so I'm going to use L again. To find out how many Legos per tower, I'm going to have to take 32 things and divide it into 4 groups. So I've got 4 groups drawn. I can start parceling out 32 things. So let's get my green and let's do that. Remember, you don't have to do this part. You're just going to need to be able to show the number sentence. But if you've got time, go ahead and solve. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I have separated it out equally. And in this case, L, whoa, sorry, super thick. Forgot to change it. L, I don't like it that thick. Sorry, guys. Is equal to, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 8 in each group. So this is a division problem. The main thing to remember, guys, is if you are given the total in a word problem that you know is either a multiplication or a division word problem, if you know the total number of items, it is a division problem. Your job today is to do some matching of equations and write some equations to match some word problems. Good luck, have fun, and let